Hey everyone, how are you doing? I have a Bachelor of Fine Arts degree in music, so I like using music examples, so here goes. This is a picture of the Vienna Philharmonic Orchestra in 2018, and I'm wondering if you see anything kind of odd about this picture. I'll just give you a few seconds. And if you're thinking, hey, yeah, I do, there's a lot of men in this picture and there's not that many women, you'd be absolutely right. So I'm looking at 2, 3, 4 women out of an orchestra of around 40 people. So that really sucks. And if we look at this orchestra, the New York Philharmonic in 2020, it's a little bit harder to see. I mean, there are many more people in the orchestra, so the people are smaller in the picture. But the string section is about 50% women, so that's good. But it skews again as you go further back. So only 3% of the trumpet, trombone, and percussion players are women. And the same holds for the London Philharmonic. So this is the London Philharmonic, and you see that women have a medium representation in the string section, but it becomes very male-dominated the further you go back. So obviously this really sucks. This is not a good state of affairs in how things should be, but one good thing is that things have improved. So way back in 1970, fewer than 5% of the musicians in U.S. major orchestras were women, and today it's around 37%. So things have improved, but we still have a long way to go. So one question we might have is, well, what led to this improvement? Even though we're not there yet, we made this improvement. What led to it? What led to it was a change in how auditions were handled. So here is a typical audition. This is to get into a music school, but symphony orchestras work in a similar fashion. Where the performers on stage, there's the accompanist and the person turning the pages for the accompanist. That person probably has a name, but I don't know what that name is. And then we have the jury sitting in the audience, right? So these are the people of the faculty of that particular department, whether it's the piano faculty, the voice faculty, in this case, the reed faculty, and they're judging how well the person performs. Here's another picture of, this time of a vocalist auditioning, and there's the accompanist there, but you have this jury listening to the performer. So this jury kind of is the key, right? They're making judgments on how the performance occurs. And just a quick divergence from the topic, a quick aside is these are really scary things for the performer. At least they were for me. So as an undergraduate, pretty much the finals week was consumed by doing these juries. So there'd be a jury on your major instrument. There'd be the piano jury and the voice jury. And the voice jury to me was like tremendously scary, right? You'd be on stage, there'd be the accompanist there, and then in this darkened performance recital hall, the voice faculty were there listening to you. And I really sucked at voice. I was not good at voice. It was just a requirement. And it was probably the most traumatic experience I've ever had. I think to this day that, if I get nervous trying to give a lecture or something, I always think back and think, well, it can't be as bad as that experience. Anyway, that was an aside. There's long stories involved there. But the thing is let me go back to this picture, that since the people, the jury, can see who's performing, there's that implicit bias that gets impacted, right? So the person can see it's a male, they think the males can perform better than women, and they're going to judge, this person's great compared to this woman we heard, even though, the woman might be a superior musician. So what this led to was having blind auditions. Here's a paper from 1997, but this is the general way it works, is that you have some sort of drapery or barrier between the performer, between the stage, and the people, the jury, listening to the person. And here's what it looks like from the performer's standpoints, right? So they can't see the jury. And this led to a tremendous improvement in how many women were admitted to orchestras, just doing it blindly so they couldn't see who you were. But there was still a rub. There was still a bias against women. And here's a picture of a person. And I'm wondering if you can think of, well, why would there be a gender bias? If they can play equally, it's blind, they can't see who the person is. And if you think, well, maybe it's the shoes, you'd be right. So people could tell whether it was a male or female performer based on kind of the sound of the shoe on stage. So now they tell people to, do barefoot, wear your stocking feet when you're performing. And this even occurs in lesser auditions. So when I gave this talk a few years ago to an undergrad class, people said, yeah, that's true. And I'm in Virginia and, auditioning for the Virginia Orchestra or whatever it was. We had to perform barefoot behind a curtain. And you may be wondering, well, yeah, Ron, this is pretty interesting. But what is this? We're not in music school. Why are you giving us this example? But this sort of bias, this gender bias, occurs everywhere. And this is just, an interesting example of it. So another case would be resumes. So this study done with university science faculty evaluating applications for a lab manager position. And these applications were identical, except one had a male name and one had a female name. So identical resumes. And the faculty rated the male applicants significantly more competent and offered $5,000 more in salary than the female applicants. And this was regardless of whether the science faculty member was a male or female. So, women were equally biased against women for this lab manager position. That's weird, but it's true. Another example is this one where they were rating applications from fictitious applicants to head a marketing department. And the only difference was that one said the person was a parent-teacher association coordinator, and the other said that they were a fundraiser for a neighborhood association. And the idea here was that if you were a parent-teacher association coordinator, you were likely a woman who had some children. And in this case, the female applicants, based on they said they were a parent-teacher association coordinator, they were judged less significantly competent and committed and got only a 7% less salary offer. So that is equally awful. This is just, it shouldn't be this way in modern America or in the modern world. So we're seeing here that we have, there are people who are making hiring decisions that have obvious biases and they don't care. But a lot of us just have implicit bias. And this implicit bias can affect the hiring of job candidates, right, as we've just seen, as I've just shown you. And the gender of a person being evaluated can significantly influence the assessment of resumes and interviews, right? So it just happens that, we have these biases, we're even unaware of them, and it's influencing how we're rating resumes, based maybe on people's names or whatever. We're making some determination that's not really based on how well the person can perform the job. So now you might be thinking, well, wait a second. People have these implicit biases. Maybe we should have computers, look at resumes and make determinations and classify resumes. This is a good candidate. This is not such a good candidate. And that's what automatic classification of job applicants would be like, right? So we'd have systems that can zip through billions of resumes and pick out the best resumes. That would be just awesome. And this would be a benefit for this reason, that on large campuses, there's permanent recruiters there. So at Carnegie Mellon, there's a permanent recruiter, at least multiple permanent recruiters there. So full-time, they're there all the time on campus. University of Texas at Austin, Stanford, full-time recruiters. When the recruiting season starts, the number of recruiters just blossoms, right? It says it's not unusual to have 20 recruiters on campus from a single company. University of Texas, Austin, 20 recruiters from Amazon or wherever. So we have this massive influx of recruiters. When Amazon comes to town looking hungrily for new hires, recruiting officers take up all 8 conference rooms at the Career Center at Carnegie Mellon. They just overflow. It's organized chaos. Tons of recruiters at these top schools. Now the question is, there's this, we're trying to find the best talent. Easier to do in these situations when you have a full-time recruiter. But what would happen, we're trying to identify people from all over the world. Where can we get this talent? And they might not be coming from the large schools. And this was one of the topics at the Virginia Commonwealth for Data Analytics and Humanities Summit that occurred, maybe 4 years ago now. And these companies were saying, there's problems in finding talented applicants from smaller schools. So like finding applicants from the University of Mary Washington, the University of Southern North Dakota at Hoople, wherever. We don't have recruiters there. We're not going to send recruiters there. It's not worth our time to send recruiters there. But how can we identify, the cream of the cream of the best people at these universities? And the solution, at least mentioned in this summit, was that, man, machine learning would help. So all these people are sending in resumes. We'd go scan them with some fancy software, identify the best people at these schools. And if you look online, there's tons of companies offering this service of automatic classification of resumes that would rank them and do good jobs for them. And even large companies like Amazon and Google are investigating this possibility. Now the problem is this. So Amazon develops this tool that helps them, this AI deep learning tool, to help sift through the tons of resumes they get. But there's a problem. Amazon scraps secret AI recruiting tool that shows bias against women. Man, even the tool we developed, the deep learning network, Amazon, a smart company filled with supremely talented people, and the tool they build has a bias against women. Same problem, just a different Fortune magazine this time. Amazon reportedly killed an AI recruitment system because it couldn't stop the tool from discriminating against women. So a real bummer. So not only are people biased against women, but now it turns out that these deep learning systems have an equal amount of bias. So all these companies that do this are a bit dodgy. Who can trust them? Right? We don't know what algorithm they're using. It may be extremely biased and only giving us, white men as possibilities. There's a lot of universities investigating this problem, and a lot of researchers, and even at Amazon and Google and Facebook and all these places, they're trying to investigate, how can we develop algorithms that don't have this bias? Here we've done a little bit of that. We've investigated gender bias in deep learning, and there were 2 students who got their honors thesis for that. One was Emma Stotz in linguistics, who worked on gender bias and Twitter, and Claire Arrington, more recently in computer science, did an honors thesis on gender bias in resumes. So that's interesting and cool. Before I kind of deviate from this and just explain a little bit about what the problems are, let me explain what Cohen's D. Cohen's D tells you is a formula. I'm not going to show the formula or go into any detail about the formula. If you're interested, you can kind of look it up. But it tells you, it's a formula that'll tell you what the effect size is. Is this a big difference or not such an important difference? So if you get a Cohen's D of 0.2, that's showing it's a small effect. And what that means, how Cohen defines it, is it's too small to be discerned by the naked eye. And he gives the example of the difference in height between 15 and 16-year-old girls. So apparently that's not much of a difference in height, and that would be about 0.2 difference. Medium effect is a value of 0.5, and that you can, if you look long enough, you can discern it with the naked eye. And his example is seeing the height difference between 14 and 18-year-old girls. Now, I don't have a lot of experience looking at the height of girls. So this is sort of meaningless to me. I mean, I kind of get the idea, but maybe that's his example, so I'm just sticking to it, and maybe it's helpful for you. The large effect, 0.8, is where you can visibly see this. It's easily observable. And he says, well, that's the height difference between 13 and 18-year-old girls, some obvious difference. Now, Cohen's D has been used to investigate implicit bias in people. Do people have implicit bias? Can we kind of measure it? And the answer is yes, we can see these implicit bias. And the most famous one is Harvard's implicit assessment test. And that works like this, that they have a number of different tests now. You can test whether you have bias against Arab Muslims, whether you have this bias that you think, women should go with liberal arts and men should go with science. Do you have a black-white racial bias? Do you have a skin tone bias, an age bias that you think, old people are blah, and young people, you have a preference for young people, and so on. Do you have a preference, a bias against Trump compared to presidents in the past? Whatever, gender career bias is, do you think that, women more are likely to be kind of family-oriented and men more likely to be career-oriented? So you can take these tests and see if you have a bias. Just search for Harvard IAT and you can do these tests. And these are well-founded, and that's where that Cohen's D comes in, that there's a good association that validates these tests. All right, with that in mind, let's see if a computer has these biases. And here is a little Python notebook, and we've already talked about word embeddings, and that's what I've done here. I just loaded one ahead of time, and it was kind of large and took my time. But I can now look up what the word embedding is for the word dog, and there it is. And now let's say we're interested in just how similar are two words. And we can do that with just getting cosine similarity. That is a measure of how similar things are, where the closer to one something is, the more similar the two words are. So let's do that. Maybe I should have done dog, dog, but you can see that the similarity between dog and puppy is 0.81. So that's really similar. Between dog and poodle, 0.65. Between dog and book is 0.08, so not too similar. So you can see that similar words have similar word embeddings, right? So puppy and poodle, or puppy and dog go together. Couch and, I don't do couch and dog, but couch and dog you can imagine would be far apart. Now let's take a simple look at these examples. So physician to he, physician versus she. So we're getting the word embedding for a physician, we're getting the word embedding for he, and we see how close they are, and we'll get them for she. Same with teacher and developer. Well, I already ran it, you can see the results, but let me do it again. And so here we see that, he is a lot closer to physician, twice as close than she is. So there seems to be this bias. You'd think that, why would that be, that there'd be some semantic feature that brings he closer together? We have some implicit bias. Teacher, the same, right? Twice the closeness for women, she, compared to men, he. And developer is even more startling, where the he is 0.08 and the developer to she is 0.052. And the reason for this is as follows. So to get these word embeddings, people use pre-existing text. So let's say you analyze Wikipedia. That's one common source for determining these word embeddings. And historically, physicians are male. So in a Wikipedia article about a particular physician, you'll see the word physician and he more often than you would physician and she. So it makes sense in the analysis stage. The data is just historical data. And if you look at Wikipedia, you'll find out that physicists generally were he's, right? So that's where we're getting the data. It's a fine representation of that data, but it's not a good thing to use then if we're trying to, evaluate resumes. Now let's go on a little bit. We're going to implement Cohen's d here. And again, that's the sizes. 2.2 is a small effect, 0.5 is medium, and 0.8 large effect. And I'm not going to run these. These take a little bit of time, and I've already done so. But one IAT, the Harvard IAT, would be to see, do you have a bias related to insects and flowers, like thinking that insects are kind of yucky or unpleasant and flowers are more pleasant, right? So we have these 4 categories of words. We have the flowers listed there, the insects, and some pleasant words like love, peace, cheer, friend, heaven, rainbow, laughter. And then we have unpleasant words like grief, poison, stink, assault, disaster, kill, cancer, ugly. And we're going to see, are these pleasant words more associated with flowers and are insects more related to unpleasant? And when I do that Cohen's d, I find that it's 0.4, so kind of a medium effect, right? So that, yes, there is a bias there in the algorithm, in the word embeddings, and such that flowers are considered more pleasant than insects are unpleasant. Here I'm comparing instruments and weapons. So are musical instruments more pleasant versus weapons? Now you'd think, yeah, musical instruments should be more pleasant. And here that Cohen's d is, and it's a medium effect again, 0.53. So that's showing that there's bias in these word embeddings, implicit bias. Now we look at male and female names to career and family, and here you see this effect, which is tremendous. It's huge. Right, so we have this huge bias, or we don't, the word embeddings do, the system we're using does, between thinking women's names are more associated with family than career names, or than male names are associated with career. So that's really unfortunate, right? So if we use these word embeddings, we're going to naturally get some bias in our system. Here's math and art, and we get a small bias, so not a big bias here. And finally, I think I compared software terms like computer, API, hardware, software, JavaScript engineer, to musician terms like violinist, cellist, vocalist, and so on. And I compared it with those male and female names. And again, I get a very high bias. So men are associated with software stuff, and women are more associated to musician. So this just illustrates that the software we're using has a bias. This word embeddings have a bias. And if we're not aware of it, bias could enter into our deep learning system. But the problems don't stop there. And for that, let me get back to the presentation. So here's an example from Nikon. Nikon, as we probably all know, is a Japanese multinational corporation headquartered in Tokyo, specializing in optics and imaging products. We kind of know what I would think from cameras. And there was a problem with their Coolpix camera. As you can see here, there's a feature that if you take a picture and if someone blinks, it'll point that out so you don't get a bad picture and can retake it. But unfortunately, as you see, it thinks these Asian people, all of them blinked. That kind of sucks, right? There's a bias there against these Asian people. And here's just another example. So these people are not blinking, but they think someone blinked. And here's an explanation. The principle behind face detection is relatively simple, even if the math involved can be complex. Most people have two eyes, eyebrows, and nose and lips, and an algorithm can be trained to look for those common features, or more specifically, their shadows. For instance, when you take a normal image and heighten the contrast, eye sockets can look like two dark circles. But even if face detection seems pretty straightforward, the execution isn't always smooth. Right? And we've kind of seen this, that, it's not difficult to detect faces because we've already kind of started messing around with convolutional neural nets, seeing that these kernels, detect different features. And one of these features are eyes, a nose, and lips. So we can, it's not too much of a stretch for us to imagine it'd be fairly easy to find it, have face detection. Here's another example. Let me play it.
Oh, Desi. This is using the video tracking software.
All right.
Explain.
My coworker Wanda and I are sitting in front of an HP Media Smart computer. State-of-the-art computer, wouldn't you say?
I'd say.
We're using the face tracking software, so it's supposed to follow me as I move. I'm black. I think my blackness is interfering with the computer's ability to follow me. As you can see, I do this. No following. Not really following me. I back up. I get really, really close to try to let the camera recognize me. Not happening. Now, my white coworker Wanda is about to slide into frame. You will immediately see what I'm talking about. Wanda, if you would, please.
Sure.
Now, as you can see, the camera is panning to show Wanda's face. It's following her around. But as soon as my blackness enters the frame, which I will sneak into the frame. I'm sneaking in. I'm in there.
That's it. It's
and
over.
There we go. It stopped. My hands are here. Wanda, please get back in the frame. Get back in. As soon as white Wanda appears, the camera moves. Black Desi gets in there. Oh, nope. No face recognition anymore, buddy. I'm going on record, and I'm saying it. Hewlett-Packard computers are racist. I said it. Hey, hold on. And the worst part is, I bought one for Christmas. I hope my wife doesn't see this YouTube video, but I bought the same computer, and we can't even use. Look, it's not following me. It's not. Wanda, get back in the frame.
It follows me wherever I go.
I welcome responses to why the HP webcam does not pick up Negroes.
All right, and let's look at another example here. Just give me a second.
Nice.
This is where a soap dispenser doesn't identify black hands.
Too black?
Too black.
Yeah.
So what I'll
Come
do...
again. Come again, Sashi. You too back over way.
What I have to do to get
What do you have to do?
that's how racialist thing is.
Yeah.
I have to use that piece of white. Let's say a napkin and show it. What's the difference?
Bring your napkin again.
Napkin again.
Right, put your hand out.
What's it called in a hand?
Man, the black man getting fight
Black
all
man
over,
getting fight
boy.
all
All over. Right.
Okay.
Okay.
Stop that.
We try now.
All right. So what's the scoop here? Are people just, these aren't bad people who are designing this. They're just kind of lack some fundamental awareness, right? So they are developing face recognition for a camera, and they don't think that their samples, the data they have, their sample size didn't include Asians, right? The face tracking software on the HP desktop and this hand washing one, apparently the people working there, weren't black people, and they didn't have a test set of people saying, hey, wait, this doesn't work for black people. So it's not an intentional thing probably, but you can see where it's just ignorance, I guess. And the more diverse workforce we have, the more people, the more women we have in these positions, the more different racial mix we have, the more culturally diverse we have, just the better products we can develop. Here's another example from Twitter that has racial bias in image previews. So it prefers white faces to black faces. So on the desktop version, you'll see both pictures, but when it gets to a mobile device, it's going to crop the picture into some smaller aspect of the picture. And in this cropping algorithm prefers white people. So it'll get rid of Obama and show that friendly Mitch McConnell. And Twitter says, we've tested for bias before shipping the model and didn't find any evidence of racial or gender bias in our testing, but it's clear we've got more analysis to do. We'll continue to share what we learn, what actions we take, and we will open source it so others can view and replicate. Well, it's nice that they're recognizing this problem and how difficult it is sometimes to first identify it, even when you're testing for it, and trying to fix these algorithms. And here's another example where if the person wears the white mask, it'll detect her face. But if she doesn't, it doesn't find her face whatsoever. She got so frustrated with this that she formed an organization, this one here, the Algorithmic Justice League, where you can go and look at all sorts of papers on this problem. Right? So what are the problems dealing with facial and gender inequality in computer software? There's this interesting book I just started listening to it. It's called Sex, Race, and Robots. And it says, in this stirring visionary work, acclaimed roboticist Dr. Ariana Howard explores how the tech world's racial and sexual biases are infecting the next generation of artificial intelligence with profoundly negative effects for humans of all genders and races. So again, this bias that's creeping in and we're just not aware of it. And no matter what we do, it's difficult to kind of identify and get rid of. So this is implicit bias. So it's implicit bias in the developers, humans, and the data we have, right? The algorithms are relying on data, and this data has bias in it because the data is generated by people. So if we're looking at Wikipedia data, news articles, whatever the data source is, they're human generated, and the human generator have bias. If you're trying to build up a tool that identifies good resumes and are using it as these must be good people because we hired them in Amazon, and it just so happened you hired all men at Amazon, it's going to pick up that difference. So these are implicit bias. We're not aware of it. We're not bad people. We're trying to do the best we can. But these biases that are very unfortunate and that are hurting people and limiting what they can do are creeping into our systems. Right, so Wikipedia is just discovering that physicists are men, doctors are men, teachers are women. If you looked at Wikipedia data, again, that's what you'd see, and that's what these systems learn. That's implicit bias. One unfortunate aspect of this is it's very difficult to study. So a company puts out some product, like here's a resume tool that'll help you identify good resumes, and researchers cannot go in and investigate that tool. It's illegal under this Computer Fraud and Abuse Act. You're not allowed to do that. In contrast, in real world things, like if you were thinking this, apartment complex is biased against black people, you could send investigators in and pretend that you were interested in the apartment and see if, the pretend ones that were white were admitted and the black ones were told, sorry, we don't have any vacancies. You're allowed to do that investigation. The equivalent with computers is prevented under this Computer Fraud and Abuse Act. You're not allowed to do this investigation of software. This is being fought by ACLU. They're challenging this big data discrimination that you should be able to study these systems. Like if you have a system that ranks resumes, researchers should be able to look at it and see if there is some bias associated with it. And the responsibility is on all of us. So this Dr. Ariana Howard that I mentioned before says, I believe that every engineer has a responsibility to make the world a better place. We are gifted with an amazing power to take people's wishes and make them a reality. And with that, I always think, well, I'm a pretty old guy. I'm pretty near retired. And I really feel a lot of positive attitude toward, young people and what they're doing. And I think the world's going to be a better and a marvelous place. Sure, it's kind of dark at times and things seem bleak. But in the long term, there's people like Greta Thunberg and, you look at what's happening. And I think that's true with all of you, that there's really a potential here that you could make the world a better place. And the world could be otherwise. So if you get kind of down on stuff and think, this really sucks and this is unfair and the world's bad and there was this coronavirus and the politicians and whatever you get worked up about, think, the world could be otherwise. We could make a difference. And instead of thinking of a job as, this is the way I'm going to make some money, get some big bucks, get married, have a great house, get some kids, think, this is a job where I can do some good for people. And that's sort of my high horse ending to the course, is that do things for good. Don't do evil stuff, do good stuff. That's sort of the precepts of Buddhism creeping in. But, that's the attitude you should have, that, I want to get a job that'll benefit people, and that'll, really make the world better. So thanks so much for listening and my ranting about this topic. Take care.